Hey everyone, and welcome back for another deep dive. This time, we're going to be tackling quantum computing.
Oh, yeah.
It's one of those things that
Yeah.
seems very sci-fi, very far out there.
Right.
But the more you look into it, you realize it's actually a lot closer than you might think.
Yeah, it really is. I mean,
And there are actual machines being built.
absolutely. And I think that's what makes it so fascinating to think about.
Yeah, so we've got some really interesting source material for this deep dive, including a discussion between physicist Brian Greene and MIT professor Seth Lloyd.
Okay.
And Seth Lloyd is actually,
Right.
one of the people on the front lines of building these quantum computers.
Wow.
So, I mean, who better to hear from than someone who's actually,
Yeah.
working on making this a reality.
Yeah, that's incredible.
So the big question we're going to try to answer in this deep dive is, could quantum computers really revolutionize everything
Mm.
from, code breaking to artificial intelligence and really everything in between?
Right. And I think what's really captivating about this field is that we're talking about computers that operate on entirely different principles
Yes.
than the ones we use every day. You know,
Okay.
it really is tapping into this bizarre world of quantum mechanics.
Yeah.
Where particles can be in multiple states at once.
Yeah, I definitely remember that from physics class.
Yeah.
But it always just kind of felt like a thought experiment to me.
Right.
Like, how do you actually go from electrons behaving like waves
Yeah.
to a machine that can, solve real-world problems?
Well, that's where I think starting with the strangeness of quantum mechanics is so important.
Okay.
Richard Feynman, the brilliant physicist, he kind of said it best. He said, if you want to make a simulation of nature, you'd better make it quantum mechanical. So he realized early on that to really grasped the universe, we need computers that operate on the same principles as the universe itself.
Okay, so that makes sense in theory.
Yeah.
But how do we actually, translate that into a functioning computer?
Yeah, well, the key lies in this concept of superposition. So imagine a coin spinning in the air, you know?
Uh-huh.
It's neither heads nor tails until it lands, right?
Right.
Well, in the quantum world, particles can exist in a similar state. They can be both up and down simultaneously until they're measured.
Okay.
And this ability to be in multiple states at once is what gives quantum computers their incredible power.
So instead of bits, which are either a 0 or a 1, we have these qubits
Yes.
that can be both 0 and 1 at the same time.
Exactly.
That's pretty mind-bending.
It is.
But how does that actually translate into computational power?
So think of it this way with just 3 bits. A classical computer can represent only 1 out of 8 possible combinations at a time.
Okay.
But a quantum computer with 3 qubits can explore all 8 possibilities simultaneously.
Wow.
It's like having 8 computers working in parallel.
Now, that's what I call multitasking.
Right.
But I'm guessing it's not as simple as just running every computation at once.
You're absolutely right. There's got to be more to it. The real challenge lies in designing quantum algorithms that can effectively utilize this parallelism.
Right.
And these algorithms are incredibly complex and have to be tailored to specific problems.
So it's not just about building these quantum computers, but also figuring out how to program them
Exactly.
to solve specific problems.
Yes.
What are some examples of those quantum algorithms?
Well, one of the most famous ones is Shor's algorithm,
Right.
which has the potential to break modern encryption.
Mm-hmm.
And that's a big deal because encryption relies on the fact that it's very difficult for classical computers to factor large numbers.
Okay.
But Shor's algorithm can do it exponentially faster.
Wow.
So it really does pose a significant challenge to cybersecurity as we know it.
So the NSA might be a little nervous right now.
Maybe so.
What other kinds of problems can these quantum algorithms tackle?
Another really intriguing one is Grover's algorithm.
Okay.
And this one was inspired by the technology behind phased array radar. And it can search through unsorted data much faster than any classical algorithm.
Okay.
So imagine searching through a massive database for a specific piece of information.
Right.
A classical computer would have to check each entry one by one.
Right.
But a quantum computer using Grover's algorithm could find it much more efficiently.
That sounds incredibly useful for just about everything.
It really does.
From, scientific research to just searching the internet.
Absolutely.
But with all this potential, why aren't we seeing quantum computers everywhere already?
Right.
Are they just too expensive to build?
Well, cost is certainly a factor, but I think the bigger hurdle is the sheer complexity of building and maintaining these incredibly delicate systems.
Okay.
Qubits are extremely sensitive to their environment, which makes them prone to errors.
Mm-hmm.
So it's this constant battle against what's called decoherence,
Oh.
where the quantum state collapses due to interaction with the outside world.
So it's not just about building these machines, but also keeping them running smoothly, which sounds like a pretty big challenge.
It is, and it requires, cutting-edge technology and meticulous engineering.
Yeah.
We're talking about controlling the behavior of individual atoms and photons, which is a mind-boggling feat.
Wow, it sounds like building a quantum computer is like trying to balance a million spinning plates at once.
Yeah, I think that's a good analogy.
So it really does sound like an incredible engineering challenge.
Yeah.
But let's say we do overcome those hurdles.
Okay.
What then, what does a future with quantum computers actually look like?
That's when things get really exciting. Seth Lloyd, who we mentioned earlier, he believes that while quantum computers won't be replacing your laptop anytime soon,
Okay.
they will excel at specific tasks that are currently impossible for classical computers to handle.
So it's less about replacing our current technology and more about like augmenting it
Right.
and opening up entirely new possibilities.
Exactly.
What kind of problems are we talking about specifically?
Well, one area where quantum computers are expected to have a huge impact is in the field of materials science. So imagine being able to design new materials from the ground up, atom by atom, using quantum simulations to predict their properties with incredible accuracy.
So we could create materials with, very specific properties.
Right.
Like super strength or super conductivity.
Exactly.
That we can only dream of today.
Yeah, and that could revolutionize everything, from the way we build airplanes and cars to the development of new energy sources and medical devices.
Speaking of medicine, I've heard that quantum computers could also have a major impact on healthcare.
Yeah.
How so?
Well, one of the most promising applications is in drug discovery.
Okay.
Currently developing new drugs is a very lengthy and expensive process, involves a lot of trial and error.
Right.
But with quantum computers, we could simulate the interactions between molecules at an atomic level.
Okay.
And that would allow us to design and test new drugs much more efficiently.
So it's like having a virtual laboratory where we can experiment with different drug candidates
Right.
without having to synthesize them in the real world.
Exactly.
That could significantly speed up the process of bringing life-saving medications to market.
Precisely. And it's not just about developing new drugs. Quantum computers could also help us understand complex biological processes,
Okay.
which could lead to, personalized medicine tailored to an individual's unique genetic makeup.
So no more one-size-fits-all treatments.
Right.
We could actually have therapies specifically designed for each patient's needs.
Exactly.
That's incredible. But I know you mentioned earlier that quantum computers could also pose a threat to cybersecurity.
Right.
Can you elaborate on that a bit more?
Yeah, so as we talked about, Shor's algorithm has the potential to crack the encryption methods that protect our online data.
Okay.
And this is because most modern encryption relies on the difficulty of factoring large numbers,
Right.
which is a task that's extremely challenging for classical computers, but relatively easy for quantum computers running Shor's algorithm.
So all of our online banking and shopping and communication could be vulnerable if someone were to get their hands on a powerful enough quantum computer.
Yeah, that's a legitimate concern. However, it's important to note that the cybersecurity community is well aware of this threat
Okay.
and is actively working on developing quantum-resistant encryption methods.
So it's a bit of a race against time. The people developing quantum computers are trying to make them more powerful.
Right.
And the people working on cybersecurity are trying to stay one step ahead.
Yeah, I like that analogy.
Like a real-life technological arms race.
Yeah, and it highlights the importance of collaboration and responsible development in this field. We need to ensure that as we advance quantum computing, we do so in a way that benefits society as a whole.
Right.
Without, compromising our security or privacy.
That makes sense. So we've talked about materials, science, medicine, and cybersecurity. Are there any other fields where quantum computers are expected to have a major impact?
Oh, there are many others. But perhaps the most exciting is the potential impact on our understanding of the universe itself.
Okay.
So quantum computers could enable us to simulate quantum systems with unprecedented accuracy, providing insights into the fundamental laws of physics, and perhaps even shedding light on the mysteries of dark matter and dark energy.
So we could unlock secrets of the universe that are currently beyond our grasp.
It's possible.
That's pretty mind-blowing.
It is, and it highlights the transformative potential of quantum computing. You know, we're not just talking about faster computers here.
Right.
We're talking about a fundamentally different way of processing information, one that could lead to breakthroughs in countless fields and reshape our understanding of the world around us.
It all sounds incredibly promising. But I also wonder about the potential downsides.
Sure.
I mean, we've already touched on the cybersecurity threat, but are there other risks or challenges we need to consider?
Well, there are certainly challenges. One is the issue of scalability. Building larger and more stable quantum computers is incredibly difficult. It's a bit like trying to build a house of cards on a vibrating table.
So even if we can build small-scale quantum computers, scaling them up to handle complex real-world problems
Right.
is a whole other ballgame.
Exactly. And there's also the issue of accessibility.
Okay.
You know, quantum computers are currently very expensive to build and operate, so access to this technology is limited to a select few research institutions and companies.
So there's a risk that the benefits of quantum computing could be concentrated in the hands of a few, exacerbating existing inequalities.
That's a valid concern, and it's something that we as a society need to address.
Right.
We need to ensure that the development and deployment of quantum computing is done in a way that benefits all of humanity, not just a select few.
Absolutely. It's crucial to have these conversations now while the technology is still in its early stages,
Right?
to make sure that we're prepared for the societal and ethical challenges that lie ahead.
I completely agree. As with any powerful new technology, there are both risks and rewards to consider. It's up to us to guide the development of quantum computing in a responsible and beneficial direction.
Well, we've certainly covered a lot of ground today,
We have.
from the mind-boggling science behind quantum computers to the potential benefits and challenges they present.
Right.
But what does it all mean for the everyday person? How might quantum computing impact our lives in the years to come?
That's a great question, and one that we'll explore in more detail in our final segment.
Okay.
So stay tuned.
All right, so welcome back to our deep dive into the world of quantum computing. We've gone through kind of the science behind it and the potential and even some of the challenges.
Right.
But now let's kind of bring it all home
Okay.
and talk about, what this quantum future might actually mean for you, the listener.
It's fascinating to think about, isn't it?
It is.
This technology, which seems so abstract and complex, could actually have a tangible impact on our everyday lives.
Exactly. And it's not just a theoretical concept confined to research labs anymore. So let's paint a picture of this quantum future.
Okay.
How might it affect the way we live and work and interact with the world?
Well, imagine a world where your doctor can prescribe personalized medicine,
Okay.
tailored to your unique genetic makeup thanks to the insights gained from quantum simulations of biological processes.
So treatments that are much more effective and with fewer side effects
Right.
because they're specifically designed for you.
Exactly.
That's a game changer for healthcare.
And it's not just medicine. Think about how quantum computing could revolutionize communication.
Okay.
We could have ultra-secure, lightning-fast networks that make our current internet look like dial-up.
Wow, no more buffering videos or dropped calls.
Right.
Sign me up for that.
And beyond just speed and security, imagine the possibilities for entertainment.
Yeah.
You know, virtual reality experiences could become so immersive and realistic that you could literally step into your favorite movie or video game.
That sounds incredible. But, I also remember you mentioned potential job displacement as a concern.
Right.
How might quantum computing affect the job market?
Yeah, it's true that some jobs currently done by humans could be automated by quantum computers. But it's important to remember that this has been the case with every major technological advancement.
That's true.
You know, the key is to adapt and focus on developing new skills that are in high demand.
So instead of fearing automation, we should embrace the opportunities that quantum computing will create.
Exactly.
It's about being prepared for the shift and focusing on areas where human ingenuity will still be essential.
Absolutely. There will always be a need for human creativity and problem solving and critical thinking, especially in fields like, quantum software development and algorithm design.
Right. It sounds like the key takeaway here is that quantum computing isn't just about building faster computers. It's about a fundamental shift in the way we process information.
Right.
One that has the potential to revolutionize countless aspects of our lives.
Exactly, and it's a journey we're all on together. The decisions we make today about how we develop and use this technology will shape the quantum future for generations to come.
So as we wrap up our deep dive, I want to leave our listeners with a final thought. Quantum computing is no longer science fiction.
Right.
It's a rapidly evolving field, with the potential to transform our world in ways we can only begin to imagine.
And it's up to all of us to stay informed, engaged, and curious about this exciting new frontier. The future is waiting to be shaped. And who knows what incredible breakthroughs await us in this quantum age.
Well, thanks for joining us on this deep dive into quantum computing.